Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Today we're going to continue factoring procedures, and we're going to talk about factoring trinomials in the form of ax squared plus bx plus c, where a is greater than 1. Okay? We already learned yesterday where a is 1, where there's a 1 in front of the x squared. Today we're going to talk about when a is greater than 1. Okay, a is going to be an integer greater than 1. It could be negative as well, but it's going to be larger than 1. It's going to be other than 1. Okay? And the procedures that I created here, you're not going to find in a book. Okay, or at least I haven't found in a book. All right? I call this the Cuban Method because I was taught by a Cuban old man one day in a library. He saw me doing this, the long procedure, the way most books teach you how to do it, which is by trial and error. And there's a lot of steps, and there could be a lot of different situations. And he just came up to me, a very nice gentleman, and he said, "Hey, look, you may want to try this." And at first I said, "This guy doesn't know what he's talking about." And then when I tested it, I was just, wow, he just blew me away. He was 100% right. It never fails. It's the best way, in my opinion, to do this. So please write down the procedures. Please focus. Very simple. And the reason I really love this is not only because it's a lot easier than the way most books teach it, but it's almost identical to yesterday's method. The whole what times what equals C, but when added together is B, that's the essence of this quote-unquote Cuban method. There's just a couple little tweaks, okay? So let's talk about the procedure, and the best way to talk about it is by actually doing it. So first off, guys, whenever you see a polynomial, I don't care how large or how small, you always, no matter what, want to see if there's a GCF. So in this case, you see a 5x squared plus 11x plus 2. Before you automatically say, oh, it's Cuban method, first see if there's a GCF. Is there a GCF I can factor from here? No. So now, once that's eliminated, no GCF, okay, let's Cuban method it. Okay? So the procedure for the Cuban method here, remember how your setup before was XX? Now it's AX. So whatever that A is, you're going to repeat it on both sides. Now, I know what most of you are going to think or say, and I know what some of you out there in the internet world, online, are saying. Dude, this guy doesn't know what he's talking about. 5 times 5 is not 5. 5 times 5 is 25. This guy doesn't know what he's talking about. Trust me, I do know what I'm talking about. This is a trick. Trust me. Just give me a chance, and I will prove myself to you, I promise. Okay? So your first setup, whatever the A is, replicate it. AX. Step 2. This is one of the new parts. Multiply the A times the C to find what I call the new C. So I'm going to multiply 5 times 2 to give me a new C. And my new C in this case is 10. Okay. Now we go back to the regular method. Now we ask, what times what is the new C, but when added together is the B? What times what is the new C, but when added together is B? So in this case, what times what is 10, the new C, but when added together is the original B, and you guys said it, 10 and 1, very good. So step 4, plug in your answers into your setup. So I've got 5x plus 10 and 5x plus 1, and I'm going to stop right there for a second. I want to make sure that everyone gets this up to here, but I mean perfectly. I want to make sure that every single soul here sees exactly what I did. If there's a single question, I want to answer it now before I get to my last step, because the last step is where the magic happens, believe it or not. Of course, the third procedure. Remember how yesterday I asked what times what is C, but when added together is B? Well, now I'm just asking my brother, what times what is the new C? Remember how I did A times B to get the new C of 10, right? Well, that's what I'm using now. So what times what is the new C of 10, but when added together is the original B of 11? In this case, what times what is 10, but when added together is 11? It's 10 and 1. Thank you, sir. Thanks for your honesty, brother. You got a question for me, my man? Is every single one of my students with me right now? I don't want you to be off by even 1 second, guys. Everyone's with me. This makes 100% sense. My brother? Okay. Go ahead. In fact, I'm going to hit pause then so you can finish copying because I really want everyone to be on the same page. Give me 1 second, audience out there. I'm going to pause. Okay, guys. Thank you for your honesty. Now, here's the trick. Here's the part that most people forget because, whatever, I get it. You're in a quiz, you're on a test, whatever. You're stressed out. You didn't practice enough. But this is the absolute most important part. Without this part, you did nothing. You got it all wrong. No joke. And I call it imaginary factoring. It's not an imaginary number. It's an imaginary factoring. And let me explain why I call it imaginary factoring. What you're going to do here, guys, is you're going to look at both of these binomials that you created. And you're going to see if I can factor any GCF out of any one of those. Sometimes you can factor a GCF out of one only. Sometimes you can factor out a GCF out of both. But you will always factor out a GCF out of at least one of them. And in this particular case, I'm going to factor out a 5, right? So I'm going to be left with x plus 2 times 5x plus 1. Now, some of you may be saying, what's so imaginary about that, Mr. Morrow? Isn't that what we always do? We just factor out a GCF. No, it's not. Technically speaking, when we factor out a GCF, shouldn't we put the 5 out here? But we're not. Because this is a trick. This is not real math that we did. This is a trick. So that's why it's called imaginary factoring. I am pulling out this 5 from here, but it's not a GCF. This is a trick. It's an imaginary GCF. So I'm taking it out of the polynomial, but I am literally just throwing it out into the wind. This is a trick. That's why it's not in any book. Come again? No, the one that comes in every book, this is not there. If it was, then I wouldn't say this was a new method. That's not in every book. Thank you. Let's do another example now. Yes, sir. If you can factor out something from both binomials, you can. Sometimes you can do it from only one. Sometimes you can do it from both. But you will always do it at least from one. Always. Okay? But you do not pull out the GCF. You just disappear it. It's gone. It's an imaginary factor. This is a trick right here. This is a trick. Because technically speaking, when you pull out a GCF, you got to show the GCF that you factored out. This is a trick. Yes, sir. You don't do anything. Can I factor anything out of 5 and 1? So that's why I don't do anything to it, because I can't do anything to it. Yes, sir. Well, being that 5 and 1, there is no factor, I can't take anything out. If you can factor something out of both, then you do. If you can't, then you don't. You're always going to factor something out of one of them. Maybe you'll factor out of both of them. Maybe not. But you will always factor out of at least one of them. Thank you for your honesty, sir. Next, let's do it again. Procedure, AX, AX. So I'm going to go ahead and do my 3x, my 3x. Step 2, multiply the A times the C to find a new C. And hold on, I forgot to do the major thing. Is there a GCF from the beginning that I can take out? No. So now I know I can Cuban method it. So I take my A times my C, and my new C is negative 24. Thank you, son. So now step 3. What times what is my new C, but when added together is my B? So what times what is negative 24, my new C, but when added together is negative 10, my B? Negative 12 and positive 2. Very good. Whoever said negative 6 and negative 4, good thinking. I'm proud of you. But negative 6 times negative 4 is not negative 24. Okay, that's step 4. Plug it in. And then step 5 is imaginary factor. Can I take anything out of this 3x minus 12? A 3. But it's an imaginary factor. So that common 3 goes bye-bye. It disappears. It's imaginary. It's gone. It's a trick. If I was normally factoring out a GCF, I would have the 3 here. But I'm not. This is the only time that you imaginary factor. The only time that you imaginary factor. And then can I take anything out of the 3x plus 2? So, ding dong, the witch is gone. I'm done. So it's almost identical to yesterday's method, except the setup, then you have to find the new C, and then at the end you have the imaginary factor. Literally, that's the lesson. And now all we're going to do is practice. But before we practice, I want to make sure that you see those procedures and you know them. Thank you, sir. Okay, let's just say that it was a perfect square. And let's just say, just for giggles, totally different question here. Let's say that this was your answer at the end. Let's say it was x plus 5 times 5x plus 10 and 5x plus 10. Let's just say for giggles. So you imaginary factor of 5 from here and a 5 from here. So it'd be x plus 2 times x plus 2. That's it. Or x plus 2, thank you, squared, yes. If you can factor something out of both, you do. Let's say that at the end, after you did everything, it came out to be 3x minus 12, and let's just say for giggles, 3x minus 9. Well then, I'd factor out a 3 from here and a 3 from here. You get me? Okay. Yes, you can factor out a different number for each different polynomial. Thank you for asking. Anything else, guys, before we continue? Okay, now, let's do it. Okay, setup. 3x, 3x. A times c to get my new c of 6. What times what is my new c of 6, but when added together is 5? Plus 3 and plus 2. Whoever says 6 and 1, thank you for trying, but 6 plus 1 is not 5. So imaginary factor of 3 from here, I've got x plus 1 times 3x plus 2. Gotta admit, guys, it's pretty darn simple. Pretty darn simple. Okay? Come again? What do you mean, what is the other way? Well, the one in the book, for example, you'd have to set it up something like this. See how there's a 6 here and a 5 here? Okay, so you would have to set up like this. You could get this 6 by going 2x times 3x or 3x times 2x, or 6x and x, or x and 6x. And then you can get the 5 by having a 1 and a 5, or a 5 and a 1, and a 1 and a 5, or a 5 and a 1. And then you start multiplying and testing. You want to go that route? Okay. So I think the Cuban method works, right? It's good. Okay. So 6x, 6x, 6 times 5 is 30. Now, what times what is my new c of 30, but when added together is 13? Positive 10 and positive 3. Good. Imaginary factor. What can I take out of here? A 2. So I've got 3x plus 5. Sorry. And what can I factor out of here? A 3. So this is 2x plus 1. Yes, sir.
So for that one, it has to, they both multiply to equal 30 and they add to 13.
Correct, sir. What times what is my new c of 30, but when added together is my 13? Yes, sir. 100%, my brother. Does that make sense? Next. Oh, I should have gone here. Sorry. So, okay, 8x squared plus 22x plus 15. Can I take out a GCF? No. Okay, so I've got 8x and 8x. 8 times 15 is 120. Very good. What times what is 120? But when added together is 22. Very good. 12 and 10. What can I factor out of here? Imaginary factor. 4. So I've got 2x plus 3. And what can I imaginary factor from here? So that's 4x plus 5. How about here? Number 6. Can't factor out a GCF. So I got 3x. 3x. That's 15. What times what is 15, but when added together is 16? 15 and 1. Imaginary factor here is 3. So I got x plus 5. And then I got a 3x plus 1 here. Making sense here, guys? How about number 7? My setup, 2x, 2x. 2 times negative 7 is negative 14. That's my new c. What times what is my new c of negative 14? But when added together, it's negative 13. Negative 14 and positive 1. Great job, gentlemen. Can I imaginary factor from here? A 2. So I got x minus 7 and 2x plus 1. Make sense? And then, last but not least, 4x. 4x. 4 times negative 3 is negative 12. What times what is negative 12? But when added together is positive 4, my brothers. Positive 6, negative 2. Excellent. I can get rid of a 2 here and a 2 here in this case. So I'll be left with 2x plus 3 times 2x minus 1. And I'm done. To be honest, it's pretty clutch. Right? Very proud of you guys. Good job. Any other questions? I'm going to leave this up because I see people writing still, but any questions on the procedures, my brothers? Promise? Awesome. Thank you for a great class, guys. Have a great day. God bless you, and I hope you learned a lot. Bye-bye.